Thanks for Zhehao's introduction of structural performance and how to select systems based on different project conditions. Now, I will introduce the types of equipment used for diaphragm wall and secant or contiguous pile walls, followed by a cost breakdown of free returning walls. Let's start with the diaphragm wall. This system mainly involves two categories of equipment. First is the grab system, which uses two jet buckets suspended from a crane. It can be mechanical or hydraulic, and it's commonly used to remove the topsoil until a determined depth is reached. Then a hydromill, also called a trench cutter, is positioned in the precasted panel. It's a large rotary cutter with vertical wheels mounted on a frame. It can cut through both the soil and harder materials, such as rocks up to 200 megapascal, which is suitable for deep excavation, and the depth can up to 250 meters. Diaphragm walls also require a slurry recycle system to maintain trench stability. This involves slurry tanks and pumps, which store and circulate bountifully during excavation. The system also includes shakers, descenders, or desalters, which remove sand and silt from the slurry so it can be reused. Now, moving on to the drilling and excavating equipment of secant or contiguous pile walls. The main machine here is the rotary drilling rig, used to bore both the primary and secondary piles in secant walls or spaced piles in contiguous walls. A variety of drilling tools, such as augers, buckets, or core barrels, are attached to the rig depending on the soil condition. Finally, excavators are also used on site, mainly for digging guide walls, exposing pile heads, and general soil removal. These are key pieces of equipment needed for the construction of diaphragm, secant, and contiguous pile walls. We can see different returning wall require specialized machine depending on the soil type, excavation method, and support strategy. Now, I will introduce the cost breakdown of free returning wall systems. All calculations based on a wall with dimensions of 50 meters long, 500 millimeters wide, and 20 meters deep. All costs are based on the unit rates from the Australian Construction Handbook 2020 and reflect general pricing for typical site conditions in Brisbane, Queensland. Let's start with the diaphragm wall. The preparation cost, which includes mobilization, setup, dismantling, and removal of major equipment, is $165,000. The guide wall installation at about 1 to 1.2 meters deep with extensions at each end is around $25,000. The main wall installation, including trench excavation under bentony support, steel reinforcement, concrete placement, disposal of surplus material, and all block outs and sundries, total is $1,050,000. A 20% overhead and contingency margin is applied across the subtotal. So the total estimate cost for diaphragm wall is $1,487,000. Next is the secant pile wall. We can see the preparation cost is estimated at $30,000. The guide wall construction adds another $10,000. For pile installation, this includes reinforced concrete pile in soft soil with boring, casing, reinforcement, and testing. So the total is $750,000. Again, a 20% contingency margin is applied. The total estimate cost for the secant pile wall is $948,000. Finally, for the contiguous pile wall, preparation is again $30,000. An additional $6,750 is included for cutting and trimming the pile heads. The main pile installation, involving reinforced concrete piles with enlarged bases, casing, and reinforcement at 0.5%, comes to $269,000. Again, a 20% overhead and contingency margin is applied. So the total estimated cost for contiguous pile wall is $366,900. This table gives us a detailed look at the cost composition of each wall with clear work packages such as preparation, guide wall setup, and installation. For details of calculation, please see full version of this PowerPoint. Thank you and welcome my teammates Peng Fei for further introduction.